Hi everyone. In the last class, we calculated sales growth for the financial data, and this sales growth was annual. So we sorted the companies, and within that, we also sorted data date, which is the fiscal year end date, and then we just lagged sales by 1 year. That means we took the previous year's observation and we subtracted that from the current year's observation, and the difference was then divided by the last year's sales. Assumption over here is that we have all the annual observations available to us. For instance, if we are lagging sales, we are using lag sales from 2011, then assumption is that it is correctly matched to the next year's sales, which will be 2012. So that means all the years have to be in sequence. However, uh, this may not be true in all the cases. For instance, if we have data for 2011, 2012, 2013 is missing, 2014 is available, maybe 15 is missing. So when we take the lags, then we are going to take lags from incorrect year. And it is not just that the sales are missing in the sense that there is a NA written in the sales column, but that entire observation is missing. Now you might wonder when this might happen in this data set. So this typically happens when companies do not have continuously available public data. This could happen if a company was public for some time, like Dell, and then it became private. So Michael Dell took Dell private. He completely, bought Dell using his money and some private equity, and then he did something called as a leverage buyout of Dell. It became a private company, so it stopped reporting any financials publicly. Then after Dell was stabilized, it started making profits. They sold the company back to public, so they made it public, and now of course the financial data is available. So you may have gaps in the financial data over a period of time. So companies, even big companies like Dell, may have these gaps. There could be some other situations where companies can do mergers and acquisitions, and so the company starts trading under some different symbol altogether, and later on in future it might just again start trading back to the original ticker symbol. So there could be multitude of reasons for why you may have gaps in your data. As such, it is our responsibility as data analysts to make sure that we actually do not fall for this problem and incorrectly calculate the change in a variable from 1 year to another year. So let me show you how to tackle this problem in our data set. So I'm going to remove my video, and you just share the screen from now on. All right, so in this data set, in this example, I'm using the D5 data set that we had calculated in the class. Remember that D5 is simply your original data set where we have filtered out all the missing sales. So original data set had 109 rows, and now our new data set, this D5, has only 107 rows. So as you can see it over here, so D5 here has 189 rows, and D5 here has D1 had 109 rows, and D5 has 107 rows. Okay. So with this, we can now go ahead and run this. This was the same code that I used in the class. So I'm arranging by company name and financial year. By the way, instead of arranging this by data date, I'm using the variable F year in this example because F year already has the fiscal year value. So the data date variable was the entire date. So it has the month and month end date also, but I don't want all those details, so I have just decided to use F year instead. And then we group this by company name, and we calculate the sales growth using this formula, which is basically sales minus lag of sale, and we divide that by lag of sale. Now you recall that we grouped it by company name because we wanted to make sure that we do not use the lagged values of another company, and we make so group by is going to subset your data set into smaller data sets, and we limit our mutate function to only the lag values from that subset, right? So Apple will not use Amazon's sales because of this lag function, and that is how we make sure that this doesn't happen. And then here is where I have printed just these variables. So I'm just, this is just a way to print it. I'm just taking this data frame D51, selecting only these variables from it, and then I'm using function head, which will show me, in this case, 20 first observations. So here we have data for Amazon, and as we expected, the first value of course is going to be missing because there is no observation from year 2009. And then we go on to the next 10 observations, and we see that again, as expected, first observation, first sales growth for Apple is missing because we do not have any observation from 2009, and correctly our code ignored the value that was above this. This is 386 billion dollars. This value was that belonged to Amazon, so that we by mistake did not bring it forward to calculate the Apple's sales growth in 2010, and that is why we correctly get NA here. So this is great, right? Now this is what we did in the class. What if our data set had gaps? So I have generated a data set called as D6, where which basically has the same columns, same rows as D5, except that I have removed all the observations which belong to year 2012 and 2015. So I have basically artificially did it, right? And I have artificially done it, and I have used this simple code for that. So I've just used a filter where I said as long as the F year is not in 2012 and 2015. So the not, by the way, look at the syntax, how I have to write it. I have to use the not, like the exclamation point, before I write my condition. And this is weird, but yeah, this is how this syntax will work. And you probably also notice that I'm using a different operator here. So this operator is nice because it allows me to compare multiple values in one shot. So I do not have to say, filter F year not in 2012 or 2015. Instead of that, I can simply use this in operator that will allow me to list all the values I want to compare with F year. So this is going to retain all the observations from D5 where F year is not 2012 and not 2015, right? So these two years are missing in our data set. So let's go down now to the same code now, similar code, sorry. So I'm going to now create a new data frame called as D61 from D6. I'm going to just use the same code that we used for D5 previously. So I'm going to arrange this, I'm going to group by, and I'm going to mutate. Now remember, what are we doing with this? I want to demonstrate that if you ignore this fact that there are gaps in our data, we are going to get incorrect values for sales growth. So here is how sales growth will look like. So again, we have first value for Amazon missing, that's great, and then first value for Apple is also missing. But now you probably noticed that for year 2013 we have a growth of 54.85% for Amazon, while previously that growth was only this is for Apple, so that growth was only 21.87%. Here that same year, that growth is showing as almost 55%, and that is because we are using here to calculate the sales growth, we are using the sales from 2011 and not 2012, because 2012 is deleted from this data, it doesn't exist, right? And this problem is what we are trying to tackle here in this example. So let's go down and let's look at my solution to this problem. So the solution for this problem is very simple. Here basically I've used the name arrange and group by, but now in mutate we use if else. So we put a condition, and what is the condition for if else? The condition is that f year has to be equal to lag of f year plus 1, and that is how we maintain that there is a exact 1 year gap between the two. If this condition is true, then we will get the sales growth, right? If this condition is not true, then we should not get a sales growth, and so our code should return a missing value, or NA, not available. And this is going to solve a lot of problems. There could be situations where it is not just 1 year's data missing, maybe 3 years data missing, but still this condition is very restrictive. It requires exactly 1 year gap. It's usually, by the way, I have not come across ever a situation where a company reported their data 2 times in the same fiscal year. That never happens, because the fiscal year has to be clearly defined in the accounting statements, and you can restate it. Restating is possible, but you cannot say that, hey, last month I reported my results for year XYZ, and now suddenly I say this month I report new results, but they belong to the same year, right? That is not going to be like 2 separate records. It has to be 1 record only. You can amend the previous results with changes, so that is okay. So that is why in the data set you will not have a situation where F year is equal to the lag year, or F year, or a situation where F year and lag year so they will never be equal in this data set. But in some other situations it is possible. So our condition is very restrictive, right? It requires a very, very specific condition, that the current year has to be equal to whatever is the past, the lag value plus 1. That's it. Only under that condition we can calculate calculate a meaningful sales growth with this formula. If this condition is not true, so that could be the entire universe of all the alternative situations. In those cases, we should return NA, right? And that's it. That's the code. So we run this code, and then we go down, and let's take a look at the output for this. So this is the output, and as you can see now correctly, our code has NA for 2013, because the previous value for F year is 2011. So our mutate function first compares 2013 and 2011, and clearly 2013 is not equal to 2011 plus 1, right? And that is why it should return an NA. And similarly for 2016 we have an NA. And so this way we have overcome the problem.